Hey everyone, and welcome to the Tom's Hardware Podcast for June 1st, 2021. As always, I'm at Tom's Hardware Editor-in-Chief Avram Pilch, and I am joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Puckett, and our very special guest, Liz Clark from Blitz City DIY. Hi Liz, thank you so much for joining us.
Thanks for having me. Really excited to be here.
So can you for our folks who aren't familiar with your site and your YouTube channel, can you tell us a little bit about yourself and Blitz City DIY?
Yeah, so I'm a kind of self-taught electronics person. So I do projects that are sometimes music tech-based or other things like that with Arduino, CircuitPython, Raspberry Pi, and I try to document them on my YouTube channel, Blitz City DIY, and yeah, just having fun.
So how long have you been doing Raspberry Pi and Maker stuff, and is this part of your day job as well?
So I've had my channel since about 2016. So I've been doing it pretty seriously, consistently since then. I first dabbled with Arduino when I was in college in 2011, but there wasn't like an electronics program at my school. It was more that I was kind of getting freaked out as I was about to graduate that I didn't know enough tech things to get a job.
I know what that's like.
Right? Yeah. So starting the channel, I kind of revisited that way. I have incorporated some of the stuff I do into my day job. I'm an AV tech during the day, which for the past year, that's meant I'm a Zoom technician. But I've done some like Windows scripting to help, especially during the pandemic. And I also 3D printed some locks to help us secure tripods and webcams in classrooms. So the my hobbies have definitely helped out with my day job.
Yeah, that's very cool. I think all of us have found some way to work Raspberry Pi or making stuff into our professional career. When I took over as editor-in-chief at Tom's Hardware a few years ago, I said we have to do more Raspberry Pi stuff. Hence, we're all here. And Les has been with us for a year, and he is the ultimate Raspberry Pi person, having been around since before it launched.
Very cool.
And Ash has been doing Raspberry Pi stuff forever and 3D printer reviews for other sites like HowChu. So we find this all very exciting. So recently you did something really heroic, which I want to call the audience attention to, which is you contributed something to the CircuitPython code. We were talking about this on last week's show, that the most probably anticipated RP2040 board came out last week. Was it last week? The week before last. And this is the Arduino Nano RP2040 Connect, the first which actually has Wi-Fi and Bluetooth built in. And when this launched, there was no CircuitPython for it, no way to use it with Adafruit's wonderful libraries that make doing things like Wi-Fi so easy. And you stepped up within a couple of days and you contributed a new version of CircuitPython, which was added to the official, your code was added to the official code. So now everyone can take advantage and use this tool the way that it should be used. So how did you manage to do that? How did you learn how to do that and decide you were going to contribute to the CircuitPython source code?
So Arduino had actually reached out to me about the board and sent it to me for the launch, and I primarily use CircuitPython, so it was kind of a bit selfish. I just prefer to program that way, and I figured since not too many people were going to have it at first, there'd be the delay after it was announced. Something I could do to maybe help the community a bit would be to try to get it into CircuitPython. I wasn't sure if I would succeed because I'd never done anything like that before. But Adafruit has just such amazing documentation that I was able to follow the guides and build CircuitPython with Git, follow along, know exactly what files I needed to change so that it would be lining up with the pins and everything, and put in the PR. So kind of went from there. I have to say, I like disclosing my mistakes. I had kind of set stuff up incorrectly with Git on my local machine. So I had opened a PR. There was a change I needed to make, but I couldn't figure out how to do it on that PR. So I commented, I was like, can I close this and start over? And like, luckily they're so nice and welcoming. They're like, yeah, that's totally fine. And then it was after closing that PR, I actually found other pins I wanted to find. I was like kind of understanding it a little bit more. So I think it ended up being a better PR. And of course, huge shout out to Lady Ada, who then went over my PR when she had her board and cleaned up some stuff so that the Wi-Fi with the ESP over SPI was working with the CircuitPython libraries. That was one thing that I wasn't able to get working on my own. So then after that, it was committed, and now you can download the UF2 to run CircuitPython on your Arduino Nano.
I mean, that's really amazing. It's really a testament to the strength of that community and to people like yourself who make it happen. I mean, we were so excited because Les and I had just gotten our boards, and I was really frustrated with Arduino IDE. I find it really a hassle to use, not nearly as nice as CircuitPython. And I had actually dropped a line to Scott Shawcroft, who we've had on the show once before, who's in charge of the lead developer for CircuitPython, and he said, "Oh, that's interesting. I didn't even know there was an Arduino board coming out, but I'm not going to have time to add that. I hope somebody else will, though." And then like 2 days later, you did. So it was that's super cool. And I know Les has had a chance to spend a lot of time playing with that board and using your code. How has it been going?
It's been going really well, thank you very much. CircuitPython is pretty much the ideal for RP2040 boards. You can't beat it, really. You've got all the libraries there ready to work, and the code is... It almost sounds a bit unusual to say, but it's almost self-documenting. You can read and understand, even if you're not, the most fully fledged programmer in the world. You can understand to a degree what's going on, and I'm going to show that later on when I do a little demo. But yeah, absolutely fantastic on the Arduino. So we get Arduino hardware, we get RP2040 Raspberry Pi brains, and we get CircuitPython. So it's the best of all these worlds coming together.
Yeah, no question. CircuitPython seems to me to be the best language for doing these microcontroller boards. Better than MicroPython, better than Arduino, provided that it supports what you want to do. So speaking of things that you do, Liz, you've spent a lot of time doing some really interesting music projects that you've documented on your channel, including I wanted to ask you about your MIDI fighter.
Oh, thank you. Yeah, I have a music background. That's how I kind of got into this kind of stuff. Was kind of the idea that you could make your own kind of music gear. So this was a collaborative Noirez from Adafruit. So it's a classic MIDI fighter, but it has Raspberry Pi Pico as a brain, and it has this little screen here, which sometimes doesn't come out great on camera. But what you can do is you can change the note on the fly. I'm not sure if you can hear it, but I actually have this going into a Raspberry Pi set up as a MIDI host, which basically means that you can connect USB MIDI devices so that they can talk to each other without having to have a computer interface. And it's going into a robot xylophone that I built, also based on CircuitPython. And so when press the notes, it plays instantly. And you can also adjust the MIDI number here. You press down the button, and now this is blinking just to let you know that's definitely the note you chose. And then you can scroll to the MIDI note number that you want and then select, and it stays. So that was a really fun project. I had the opportunity to do a write-up too for Hackspace Mag, just kind of talk about the process.
Wow, that is really impressive. So how does the xylophone work? Is there like a robotic arm or something that hits the note?
Yeah, so it's actually little solenoid motors. And before that project, I didn't know what solenoids were, but they're these little kind of square things that have a little hammer that comes down, and it strikes the note. So that was another collab that I did with Nay, where he built a mount out so that I could mount the solenoids so that they're directly above the note, so that it sounds really nice when it strikes.
Wow. So how did you 3D print that design? Did you create that design?
So that was Nay. He's designer for Adafruit. Does a ton of really awesome snap fit enclosures for 3D printing, and same for the Xylophone too. It's actually these little mounts that go onto aluminum extrusion, so that it's totally modular.
Wow, that is really impressive. I especially love the fact that you can see that there's like a little window so you can see your Pico, so you can always see what you're using. And
yeah, we that's actually a piece of milled acrylic, so it kind of like slots in there. And we did that so that people would know it was Pico based. Otherwise, it just looks like another box. So that gives a little bit of a flair. And I also did some engraving on some other ones too, so that it has a little bit more fancy.
We need to call out a little bit of attention to the choice to use the arcade buttons that light up when you press them, because that is spot on.
Yeah, I love LEDs, and there's actually a board that Adafruit makes that's basically a GPIO expander, so it gives you more ins and outs. So as a result, we're able to, instead of doing kind of daisy chaining, we can have the LEDs directly affected by the code, and also able to do a little more fancy stuff, like when the button blinks when you select the note, which makes it a little bit more intuitive.
I love it. It's clever.
yeah, that's great. So what did you use to print it? What type of device did you use to print it?
I use a Prusa Mark II S. That's the printer I have. So it's getting a little older now, but it still prints great.
So were you able to, what parts of it were you able to print, and other parts that you said you had to mill the translucent plastic.
Yes.
What parts were you able to print?
So this case is actually, let me make my camera a little bigger. This case is actually 3 parts. So you have the top lid, the center, and then the bottom. So that's all printed. And then there's 2 brackets in here that hold the hardware. So we're using screws to mount it to the brackets. So basically everything is 3D printed except for this little window here. But I also include an STL to print if folks didn't have access to a mill.
Wow, really fancy. It looks fantastic. It looks like it was like molded. Really,
yeah.
It looks like a bought product. You go in the store and just pick it up. The professional finish is lovely.
Yeah,
He's an amazing designer.
That's great. As I have shown previously on this show, at one point, my son and I tried to make a retro arcade box, putting buttons like that in the box, and it was so difficult to drill holes to get the exact right size hole to put an arcade button in. So
and then you have to line them up.
Right.
Yeah.
So
okay.
That's really impressive.
Thank you. This is actually the second MIDI fighter I've made. The first one I made a few years back. It was one of the first Arduino and music tech projects that I did, and I didn't have a 3D printer at the time, so I used wood to make the enclosure, and I had the same issues, figuring out how to lay out the holes, get the right size hole. It sounds easier than it is.
Yeah, no doubt. I was also shocked by just how long it would take to drill a hole in a piece of plastic. I would have thought it would have just taken a few seconds, but it would take like 3 minutes or something to push it really.
And then you have to clean up the edges with the Dremel, and it's just a mess.
Yes, and like little plastic dust everywhere. So that's really impressive. You're able to print it with the holes. I assume that it printed with the holes already in it.
Yes, yeah, it's all has the cutouts for the screen, the switch here, and the Pico. So it's all set.
What software do you like to use when designing things in 3D?
So I also know uses Fusion 360. Yeah.
Oh, fantastic. And I saw that you have an even newer video. I don't know if this is a Pi project or not, but I am really curious about it, where you have something blow air into a recorder to make music that way.
Yes. I can actually might be able to lift that up. I have a kind of an ongoing project box up to the side. But I really like making music tech projects with robots. I like the idea that it's like automated and you can kind of make some sounds that otherwise, humans might not be able to do. So this is going to be the Robo Flute. It's a work in progress right now, but it's basically just a plastic recorder. It's again solenoids right now, where there's flexible filament on the ends that push down to cover the holes, and then it's an air pump on the other side to make the flute make noise. So definitely like prototype right now, and because these do suck a lot of power, so I'm not sure if long term that would be the best solution for this, but there I was getting some notes out.
You're going to put Disney parks out of business with that level of creativity.
Yeah, that's amazing. So what is the controller you're using for that?
So that I'm probably going to use an RP 2040 based board. Not sure which one yet, but they're just nice and fast, run CircuitPython. So best choice right now, I think.
Yeah, no question. And what we've found out today is that the news today is that you can now buy an RP 2040 chip by itself. Not sure what you would do with it, but
it's been on my bucket list for a while to design a controller board. So I might, especially with the chip shortage right now, look into maybe designing a board around a RP 2040.
Yeah, it's going to be pretty amazing to see what people can do with that. I mean, just having the chip, that could be great. I would like to see somebody build a full-size keyboard with one. I would like to see somebody build a game controller with one.
I think it's neat how we've seen some people already create boards that use the RP 2040, but they had to desolder it from an existing Pico just to use it in their project. So it is good that they finally released those.
Yeah,
definitely.
And super cheap too. It's like $1 per chip.
Yep.
Can't beat that.
Yeah. Of course, I don't know how much it would cost to actually turn that into something. Probably more than $4.
True, because you do need the crystal and the RAM and everything like that to have it working, unlike other chips, but it's still pretty great.
So
I'd love to see someone do a project. There was a project in UK called Shrimping, where it took a bare Atmel chip, 80 mega F328, and made an Arduino on a breadboard. I would love to see someone build an RP 2040 in a breadboard just because they can, for no other reason. Yeah. That'd be ace.
Yes, and whoever does that, we promise to cover it on our website. We will put it on the homepage. So, Les, you've been fooling around with a new RP 2040 board that you just got in the mail, correct?
I have indeed, yes. I've had this in my possession for about a week, and I've been sworn to secrecy about this. But it's something new. It came out today. It's from Citron, and it's the Maker Pi RP 2040. And I have to say, it's quite a good-looking board. I'm going to switch to my other camera now so you can see it. And hopefully you can still hear me. There we go. Lovely purple board. Looks nice. But what's really important on this board is the top row. So we've got top left, a lithium-ion lithium polymer battery connection. So we can plug in batteries to this and have it battery-powered, or as a UPS of some sort. The green screw terminals are the power inputs. We can plug in an external power source up to 6 volts. Just next to that, 2 motor outputs. So we have an H-bridge motor controller. It's the MX1508 by the look of that. We can make robots with this board really easily. And that's one of the key features of the board. This isn't a board like the previous version, which was a multi-purpose board. That was the Maker Pi Pico, which we reviewed about 2 or 3 months ago now. That in itself is a fantastic board that uses a full Raspberry Pi Pico as the guts of the hardware. This is a slightly smaller board aimed more towards robotics. So looking at the top right, you can just see slightly obscured. You can see 4 servo connections, and I've got some servo to demonstrate here. Going around the board, we've got 7 Grove connections for the proprietary connection to plug in external components without messing around with wiring or having to worry about polarity being incorrect. We've got a buzzer, because we always like buzzers, and we've got 2 NeoPixels. We've got one there and one there, because NeoPixels are cool. And this is all powered by CircuitPython. Now, the previous board came with MicroPython by default, and it works really well. But when you put CircuitPython on, it was just a whole new world. You could do everything that you wanted and more with that board. And this one, again, is a very similar thing. So with CircuitPython, I've got a quick demo set up here. You can see, hopefully, the shot is framed correctly. 2 servos and a little DC motor just here. And if I press one of these buttons, you can see it all whirs to life. And the lights come on to show me what GPIO pins are working. And awesome. Really cool. And again, all in CircuitPython, including, which I write when I just turn it on. Let's just see if this works. Hopefully I'm going to get a copyright strike for that. I just love the fact that we've got this buzzer, which is a really simple method of output, but we can make simple music with it. Now, this board is geared towards robotics. It's not going to be the all-purpose board like the previous one. There's no Wi-Fi, there's no micro SD card, and there's no audio out for a 3.5mm jack. But for $10 for this board, we've got a fantastic robot platform that we can build robots straight away, no messing, just plug in our motors, plug in our sensors with Grow connections just down here, and away we go. And we're going to be reviewing this board this week.
Very nice, Liz.
Wow.
Super cool.
Yeah. So we have a question from the audience. Will Python become like Linux with multiple styles and applications? Liz, what would you say to that?
I think it's kind of becoming like that, especially with Python on hardware. There's even kind of 2 flavors of that. You have MicroPython and CircuitPython. So I think so. And I think that's really cool because I personally prefer to program that way. More options is great.
Yeah, I think we're already there, right? Because you have many different flavors, and we have lots of talks about which is better, CircuitPython or MicroPython.
It's just
Really?
inevitable with open source.
Yeah.
Because everyone's going to fork off with their own improvements, and then you have little pockets that are optimized for whatever you're working on.
Yeah.
Well, for me, being an old man, it reminds me of the Commodore 64 era, so the 1980s, where we had different variants of BASIC. So Microsoft BASIC, we had Acorn BASIC in the UK, BBC BASIC, that sort of thing. And each one was slightly different to the other. And everyone, there was camps in school playgrounds about, what do you use, or what computer have you got? And in the UK, it was Commodore 64 or Spectrum. And wars were fought on the school playground for those machines. But it doesn't matter, because each computer, each method of BASIC has its own charm and its own way of doing things. And it's the same with MicroPython, CircuitPython, full-blown Python. They've all got the same core, how they handle things, input, output, printing, stuff, that sort of thing. But they've all got little variants that make it just better than the other for certain jobs.
Yep. So speaking of certain jobs, this is the first of the month. So this is the time when Ash highlights the projects of the month, which we've been doing now for exactly a year, right?
Yep. It marks 1 year this month.
It's 1 year this month, and also 1 year today that Les has been working with us full time. So really, I'm really happy about it and honored and privileged to work with Les every day, and I'm glad we've been able to keep him from pulling his hair out, that he's still here after a year. So anyway, Ash, what is on this month's list of great projects?
Okie doke. So just for those watching who might not be familiar with what we do, we cover Raspberry Pi projects all week long on tomshardware.com. And once a month, I have to pick 10 of them for this list that we were just discussing. And that's really hard to do because I wouldn't consider these favorites. All of the projects I cover are phenomenal, and the ones that I don't cover are just as good. It's hard to pick which ones make it to the website. So what I want to do today is share with you guys 3 projects that should get you excited. And if you like them, you can check out the full list at tomshardware.com. So I'm going to switch my display over so you can see my screen, and I'll try to say what's going on for those of you who are listening. So the first thing that I want to show off is this Raspberry Pi Robotic co-host. This is I think it's technically an animatronic because it has matrix eyes that rotate on servos. It has a little matrix mouth that can be synchronized with text-to-speech software. And you can check him out on Hot Spark Lab on Twitch to see him in action. He's actually used as a co-host in real time. You can see in this picture he has a green screen behind him, and he responds to people who join the stream, and there's apparently plans in the works to add all kinds of new features. Check out this post, look at the original thread on Reddit, and he'll sing you a song. Have you guys, while I have this brought up, have you guys seen a Raspberry Pi animatronic before?
Nope.
Yeah, because this one seemed like a first to me too, and it makes sense if you're going to control a bunch of servos, like maybe with Les's board that he had. I think maybe people need to use more Pis for animatronics. That's just me. So next up, I wanted to show you guys this Darth Vader Raspberry Pi Pico PCB cryptocurrency tracker. That is a mouthful, but it's really cool, and that's not. I don't just say that because it's shaped like Darth Vader. As the name suggests, it's made for tracking cryptocurrency prices using the Raspberry Pi Pico, and it has a little spot reserved for an LCD display so you can get visual output. It's not just sending a text with prices or anything like that. And I don't know, the Darth Vader design is pretty cool, but maybe a Boba Fett one would be neat to pair with it. What do you guys think?
Yeah, definitely.
Yes.
Yeah, that would help. And the last one I wanted to show off is this Raspberry Pi Pico Pong game. This maker created a game of Pong on the Pico using a Pimoroni unicorn module, which is just a matrix of LEDs with some buttons on the side. There are 2 on the left and 2 on the right, and those are the buttons that players can use to control the paddle. And what I like about this project is how much work she put into the design. Even though it's just a matrix, there's a little trail of fading LEDs that follow the ball as it bounces back and forth. So just credit where it's due. This is a really cool Pico gaming project, and I look forward to seeing more games on the Pico. And personally, I'm waiting for the first Pico Doom port.
There you go. Yeah, I mean, I would love to know, and my 9-year-old son would absolutely love to know when Make Code Arcade is going to come to RP 2040. If there's a way to make Code Arcade come to RP 2040, as you can do Make Code Arcade on some hardware that's lower end than that, so that he could take the games he's played on that and you make a console. As longtime viewers know, I've been on a quest to try and make some good games using a matrix. Right now, I have this one hooked up to a Feather RP 2040 using Adafruit's Feather LED matrix Featherwing, and have gotten this to draw some things. But our ultimate goal is to hook up some potentiometers to it and use it to make a Pong game on this that you can go back and forth, and also use it to make an Etch-a-Sketch, like a multicolored Etch-a-Sketch, so you could draw X and Y with it.
But can you shake it to clear the image?
That's a good idea. We would need to put an accelerometer on the back of it. Right now, the way that I have this mounted is separately, but you actually can find ways to mount this on the back. So, although I would still need an accelerometer anyway. So that's a good point, though. It would be cool to have an accelerometer so you could do it. I'm actually surprised nobody has come up with an e-ink style Etch-a-Sketch. Although I guess e-ink is too slow because when you're drawing it.
I actually tried over the winter.
Oh, wow.
I was using Adafruit's MagTag with their library.
MagTag.
Yeah,
yes.
They incorporate partial refresh. So I was getting it to go, but it wasn't as speedy as I was hoping for. But it was a cool proof of concept. Yeah, exactly. Yeah.
I have so much stuff here and so little time to program it. It's like there's so much stuff I'd like to be doing with the MagTag and would like to be doing with these different things, and there's never enough hours in the day. And then my son, who's 9, and I always do things together, so it's like, oh, I want to program the MagTag today. No, we're programming a robot today. That's his thing. So in spirit of that, I wanted to show a project which is something that actually my 9-year-old pretty much put together pretty much by himself. This is a Pico-Powered 2-wheel robot. The chassis and motors come from Adafruit. That's a 2-wheel chassis, but you still have to put together. It's got three levels, which is why we got it. On top of it, what you see is the Catronic robot Catronic Pico robot board, which can control up to, I think, 4 DC motors and a bunch of servos. But the reason we really wanted it, even though this only has 2 motors, is because it will take power from a battery and then power the Pico and the motors and anything else. So on this mid-level here, we have a pack with 4 AA batteries. So that's how little power this uses. But there's no fun if you can't actually control it. So here we have an Adafruit Airlift Wi-Fi card, which uses the ESP32 Wi-Fi chip, which is the same one you find in pretty much everything else, including the Arduino Nano RP2040. So what we did is, so I helped him with the he pretty much put this together, but I helped him with the software. Although he wrote his own library for it too. But I'll show you on my screen here. So here we have this in Thonny, and this was a challenge because we had to do this in MicroPython, not CircuitPython, as I would have liked, because the Catronic board, the Catronics library that powers the board, is only in MicroPython, and I could not figure out how to maybe convert it. So I was trying to figure out, how do I use this wireless card, and what I figured out is that Pimoroni has a library for their Pico wireless, which is also ESP32. So if you use the same pins that they are using, because the library doesn't seem to allow you to change the pins, what pins you're using, then you can use it. And to make a long story short, it will create a server. So what it does is we've created a bunch of different things to draw the HTML. And what happens is you get a web page like this, and you can hit forward, and it'll start moving forward, stop, and it'll stop, left, right, etc. To make it drivable. And this is very much like using Flask on regular Python. So that's we are looking to add some more features to it. Namely, you'll notice that it has an ultrasonic sensor on it, but that's not working yet. We want to have an obstacle avoidance mode. And then the other thing that my son really wants, and again, hard to do without CircuitPython, is to use these NeoPixel strips to have some RGB lighting on it. The other thing I think we'd all love to have is a camera, but so far we haven't had a lot of luck with using the ArduCam. ArduCam has an SPI camera, and I have not found a library for doing that in Micro or CircuitPython. Have you, Les?
I could have sworn it came with a MicroPython library. It's been a few months since I've looked at this board, but I could have sworn it did.
Okay, maybe I'll have to look into it. We did not. The thing that we had for doing the facial recognition was, I think, a C, some type of a C library, and that did not, which Les showed on a previous episode where we got the ArduCam. So yeah, I mean, it's always a work in progress. There's always more robots to put together. You have chassis in various states of disrepair. This one might be for the Arduino. Simon asks, did it need any soldering? No, not this one, not at all. So far, everything was screws. That being said, we probably would be better off doing some soldering on some of these, because we used a whole bunch of jumper wires, and so he used a whole bunch of jumper wires, and so some of them were too long and some were not long enough. So you have jumper wires to jumper wires, and it's a giant mess. So it probably would be wise to I don't know, create some custom wires either through a crimper or through some soldering. Well, actually, I should take that back. There was soldering, but it was before we built this robot. The Pico itself, I had to solder the headers onto, and this particular Pico, I used stackable headers. So Pimoroni has these. They're female on the top and male on the bottom, so it can plug in here, and you can still wire things through to the top. And similarly, the Airlift card, when it came, did not have any. I had to solder the pins in. So yes, there was. I guess when I look at it that way, there was some soldering. We did that a lot before we ever created this robot because I had to solder that stuff when I got it. So I have to ask Liz a question we ask all of our guests, which is how many Raspberry Pis do you have?
Oh,
We count Picos.
well then that's probably about 15. I do try to use the pies, though. If I notice like a few of them are stacking up around the house, I'll try to find a project where it can be kind of a headless thing. Like I use one as an Open Media Vault server for network storage, the MIDI pass through, and then I'm working right now on building one up as a media server for streaming. So.
That's great. My problem is every time I start a project with it, my son comes while I'm in the middle of the workday and says, "Oh, I want to try something on it," and then he takes it, and then something happens to it. I must have like 20 of them now. Anyway, I wanted to thank Liz so much for joining us. It's been such an honor and a privilege. Where can folks go if they want to see more of your projects?
So I'm at Blitz City DIY on Twitter, Instagram, and it's also my channel name. And I also have a currently ignored website, blitzcitydiy.com, but I do post bigger updates there.
Great. Well, thanks to everyone. As always, you can find us here at 2:30 p.m. Eastern, 7:30 p.m. UK time on Tuesdays, and we will see you next time. Bye, everyone.